Hello and welcome back to the video game development and design tutorial series that I've been working on for you. A while ago, I said that I was going to make you a user interface thing per request, and that I would also pair that with a level editor because they kind of go hand in hand, since a level editor is mostly just user interface, and you're going to need one of those eventually anyway. So here's what I've got. It is not complete yet. But we're most of the way there, and I've got plenty of material to put into videos. So you can see it loaded the map. There's nothing to scroll to the right for, which is why the bottom scroll bar doesn't work, but we've got scroll bars. You can scroll up and down like so, as long as the mouse is colliding with the scroll bar. I can pick up tiles and move them around. You can see it snaps to a grid here, which is quite nice. We can hold shift and hold right click, and we can delete a whole bunch of tiles as long as we just, mouse over them all. We can pick up a tile, move it somewhere else, pick up a tile, hold shift, left click, and then just place a whole bunch of that tile. Maybe I don't like this tile, and instead I want, say, this tile right here, so I could just click on this one in the UI, and it will spawn a tile at my mouse that will snap to the grid. If I move outside of the grid, it will not snap to the grid. So you can see I can't place anything outside, but I can place inside the grid like that. The tiles change color there because I have different texture folders for this UI here and the actual tile entities, which is easy to change. I'm just lazy. Saving and loading both kind of work. That'll be way down the line though. So for right now, we have a whole bunch of user interface stuff to deal with. And then we have to actually make the editor, and we have to deal with the state machine, and all that stuff. So let's get into it. Alright, so we're going to go into our project, game tutorial here. Go into source and core. Alright, so we're going to start off, and we're going to add a few things to the UI stuff I had been dealing with. Okay. Like so. Alright, so I want to be very explicit about what I mean or what I want all of this stuff to be for, okay? The idea here is that we basically want a state machine, okay, and that's what this guy is for right here. Basically want a state machine that tells us what kind of processing events are going to be happening in each window. Okay, so if I wanted to have some, display, right, some window open, like I had just shown, like this thing right here. Okay, so this is a window, right? There's stuff being rendered. Okay, we seem to have a bunch of tiles being rendered here. We've got like some components, like some UI stuff over here, right? So all this stuff is inside of a window. I would even call it a panel. Okay, so I would call this a display panel. All right, everything that you can see in the window right here, this is all a single panel. And the panel, I want that to just be the thing that determines like the positions of all the elements and, all of the like the colors of stuff and the sizes of things, right? But I don't want it to handle anything else. I don't want it to handle user input. I don't want it to handle math processing. I don't want it to handle any kind of events, nothing like that. All I want is this panel to be attached to a state. Okay, so then the state is the thing that's gonna handle all the processing, okay? And so if we develop the system like that, then we can have, two states attached to a single panel. And based on where you click on that panel, it could swap between states. Okay, so the same panel could have many different ways that you can interact with it, and many different things that can be done with it that have like totally different behaviors because we're swapping around these states, and the states determine the behavior of what's happening in a panel, okay? And likewise, one state could have multiple panels. So maybe you want to click something on the user interface, like File or something like that. Maybe you want that to drop-down menu. These don't do anything at the moment, by the way. But maybe we want it to have a drop-down menu or something like that when we click on File. And then perhaps that drop-down menu, we could click Save As or something like that. That'll open up a new display panel, which is the Save As display panel, but we don't want to forget everything that had happened in the previous display panel, right? So what if we just had a state that contained all the memory for like the map here and all of like the positions of the scroll bars to the offsets and stuff like that, right? The state can have all that information in it, and then it can just swap display panels. So now our display panel shows us, saving information, right? So the name, the file type, where we want it to go, stuff like that. And then in this display panel, when we click save, the state remembers everything that had been in the display panel previously, right? So it's just an easy way of swapping around what's on the screen with what's happening in the back end, okay? So we'll call the state the back and a display panel the front. Okay, so we've got front end and back end. And maybe we could have more than, multiple things happening in between the front and the back end, okay? And I'll get into that in a moment. But the idea there is that all the heavy lifting happens in a state, and all the rendering and the drawing and stuff, that just happens in display panels. And so we can sort of swap between states and display panels in whatever order we want. And that order is going to be determined by the state machine. So the state machine will determine swapping states, and it will render the current state, and the current state will contain a display panel. So right here I've got a state rendering all of its components, and we're actually going to change this quite a bit in a moment. So that a state just has a single panel, and it renders the panel and nothing else. And then the panel is going to deal with all the components and the placing and stuff like that. So then comes the question there, well, what if there's information that's easy to get in the front end, but we want to have in the back end? Okay, so what if we want the front end and the back end, so the panels and the states, to interact with each other in some way, right? So maybe, for some reason that just happens to be easier, and I'll show you in a moment, it will be easier to do it that way for a few things. So let's say that we need some form of communication interface. Okay, well, we don't necessarily want the panel and the state to both reference each other, because this kind of circulatory referencing is sort of against the object-oriented paradigm in certain design aspects. And we really want to stick with the object-oriented paradigm as best we can, because it's going to make some things like this a little bit inconvenient, but it's going to make a lot of other things much easier for us. So in general, we're going to try and make this as strictly object-oriented as we can, and we're going to try not to have many circulatory references. So the way we're going to do it then is we're going to make a just a little protocol that allows display panels and states to communicate with each other. And we've already done that, actually. It was called the command. Here we go. So the command design pattern. And so this is very, 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 very straightforward, very simple, right? You can see that in this abstract class we have basically nothing. We've just got a target. We have a constructor that is the command. It takes in a target and sets its target reference to whatever you give it as the input in the constructor. And then you have this abstract function that returns an object. It's called execute, and it takes in an array of objects as inputs, okay? And so this is just super, super abstract because it's going to allow us to make a command that can do all sorts of things, and it doesn't care about what the data type is for whatever you're trying to do with it, okay? So we just want one command, or, one abstract command class that can handle any kind of data type for all sorts of different things. And then we're going to implement that in a whole bunch of different ways, depending on what we're trying to do. Okay, so the idea is that we want a command to be a single function that does one thing. All right, and so for example, if I run my thing here, if I mouse over a tile here, okay, so these are just textures, right? They're not physical objects or anything like that. My mouse is currently interacting with the display panel, right? Like I mentioned, so we've got the front end and the back end. So right now my mouse is just on the display panel. So if I click over here, right, I'm clicking on a UI element. Okay, my mouse is interacting with a UI element. And so if the UI elements are all in the display panel, but I want all the logic to happen in the state, then it's going to be much easier for me to figure out which UI element my mouse interacted with from the display panel, because the UI elements are all already up there, right? So if I had a way for the display panel to communicate with the state, it would be really easy for me to just be in the display panel and say, oh, element has been interacted with, and then pass some information about that down to the state, okay? And so it would be really helpful if I could have a command to do that. So every time I click on this, right, on a tile or any of these tiles, right, or any UI element really, I want to have a command that says, well, there's been an element that's been interacted with on the UI, and something happened with that. Okay, it's some specific thing has happened, and I want to send the information about that specific thing down to my state. And so that's what I'm going to use a command for. So every time I click here, it's going to trigger a command, and you can actually see in my console here, I have it printing that out, so you can see selecting tile, right? So that means that the user interface, the display panel, has been interacted with, and then select command executing. Okay, so that means that the user interface has figured out that what I tried to do here when I clicked was select a tile, okay? And then it said, okay, well, if you're trying to select a tile, then that means we need the command associated with selecting a tile. And I can probably even show you what that looks like. It's really straightforward. If I go into my dev environment here, which is a separate project from what I'm showing you, you can see I have a whole bunch of commands. If I can go in here, commands. Okay, so select tile command right here, very straightforward. Okay, this is all the code for it right here. So it extends the abstract class command. The constructor is just, the default command constructor, really. And then execute. Okay, so it'll take in some inputs. All right, it prints that it's executing. It will cast its target to the editing state data type, and then it will call the select tile command inside the editing state. And with that, it will pass an argument that is of the type tile component, and that'll be the 0th index of the input array. Okay, so remember the input array is a bunch of objects, so it doesn't really have like a strict data type. And the editing state command the editing state method that I've developed here, select tile, requires a tile component object, which we'll make, don't worry. So we're just going to cast the 0th entry of the inputs to a tile component and pass that to the function. And so there we go. So now we have just interacted with the user interface, and that information has been processed. A command has been executed, and that has gone down into the state and pass some information to that. And then the state goes and does whatever select tile means. And so I'll get into that in a little while. But you can see that's kind of the flow of interaction, okay? So it's going to be the user, right, controlling the mouse is going to interact with the user interface, right? So they're not going to interact with the states. They're not going to interact with anything, logical or anything on the back end or anything in between. The user only interacts with the front end, okay? And that's display panels in this case. And so the user interacts with the display panel. A command gets triggered from the display panel down to the state with a bit of information, and then the state does a bunch of stuff. And so now we're dragging this tile around, and all this new stuff is happening on the screen because the state has told the display panel what to do now that we've selected a tile. Okay, and so all this logic for dragging the tile around, this is all happening in the state. And all that good stuff. Okay, so I can right-click and delete it, and that's another command right there. Tells the state to drop the tile, and then the state removes that from the display panel, so I no longer see it. The object itself gets removed from the state. Okay, so all this interaction is happening here. And, it may seem like it's a little bit of maybe overkill for what we're doing. Okay, so there's definitely a more straightforward way of developing strictly this screen that you're looking at right here. But what I've just described will allow us to make very robust user interfaces, okay? So that method of workflow could be applied to anything. It doesn't have to be a level editor. It could be all things that are, user interfaces, okay? So in the game itself, right, maybe you press the escape key. Well, what is that, what do you want that to do? You probably want that to open up some kind of pause menu, right? So when you press the escape key, currently speaking, the user interface should be on the player UI, maybe, right? Like we had briefly thrown in earlier. Well, if the user interface is on the player UI and the escape key is pressed, then that tells the player UI state to say, okay, stop allowing inputs, right? So stop allowing us to move around and pause the game. Okay, so stop updating the game, stop the update cycle for the main game, and then start up the update cycle specifically for the user interface. Okay, and so the player state could do all of that stuff on the back end, and it would be totally separated from everything else in the game, right? And then all it needs to do is interact with some display panels like we're doing right here, okay? So maybe some buttons, right? Save and exit, options menu, change character, whatever you want to do, right? Resume game, stuff like that. So these are just display panels interacting with states, and all of this is happening without us having to touch the code for the actual game. Okay, so the user interface here is going to be basically separated from the actual game as much as we can. And this is going to allow us to make user interfaces, again, just for everything, everywhere, right? And you could even take this outside of this project if you need a user interface or something, and make whatever you want, wherever you want. So this programming paradigm is, again, maybe a little bit overkill for specifically just a level editor, but again, this is going to be very robust and hopefully will be very useful to you in the future for any other projects and in the rest of this project. Okay, so that's basically what we're going to do and why we're going to do it. So let's get started. We need to throw a few things in here into this state, I guess is where I'll start. Actually, yeah, so a state is going to need display panels. Okay, so we have a little, a package for states, commands, and components. And so what we're going to do is we're going to make a new class, and we'll make a display panel. Okay, and this is going to be an abstract class, display panel, like that. Okay, let's think about what we need for this. All right, so like I mentioned earlier, this is going to be the thing that displays stuff on the screen. Okay, so it's going to have some UI components in it, right? Like these things that we had described earlier, right? Some UI components, and it's going to, let's say that we'll make it so the display panel is going to be responsible for initializing the components, sizing them, so scaling them, rotating them, coloring them, and then sticking them to each other, and then processing input that happens to those components, rendering the components, obviously, updating the components if maybe we want them to be animated or something like that. So the display panel is really going to be all about these components, is probably how we want it to be. So let's see. We're going to need a protected array list of component, and we might call that, we'll just call it components. I call it elements in my development environment, but I think components is a little bit more fitting. So we're going to need to import array list here. Let's throw in maybe a protected component, and we'll call this the background. So maybe you want to have like a splash, image that fills up the window just in the background, something like that. So we'll just make a special component just for that. Maybe we won't need it, but this seems like it's a safe bet to just throw in here for now. We're going to want a width for this and a height, just so we can know the boundaries of each display panel, because they might be different. Depending on whether or not you want multiple display panels in the same window, so you can have them line up side by side or something like that. So we'll just keep track of the size there. With that, we're going to need protected. What is this? Protected. There we go. I don't know why I can't spell. We'll make a integer array that is the position of the display panel here. And we'll give it a constructor. So public display panel, we want it to be given, let's say, a starting position, and then probably the width and the height. Okay, so we will set our pos 0 equal to position 0, and our pos 1 equal to position 1. And width equal W, height equals W, or sorry, height equals H. And that seems like it's probably fine. Now, this, remember, is an abstract class, so this is guaranteed to happen every time any instance of a display panel. So any display panel that we make from here on out is going to have this happen. But we also want them all to be doing different initialization stuff, so maybe we will have each display panel responsible for initializing its own components, because we know that it's going to have its own components. You know, all of them are going to have different components, right? So we're going to need to make that, so we'll do a public abstract void init components. Doesn't take any arguments, and we'll just make things implement init components. Okay. All right, let's do, I'll keep all the abstract functions right up top here. So this will be where we put abstract functions like that. We'll just throw them all up there, just keep them out of the way. All right, so let's make an update function, and that is basically going to just loop through all of our components and update them if they need to be updated. So let's, oh, and it'll also do the background as well. So let's check if our background is null, and if it's not, update it. Okay. And while I'm doing this, we are going to throw in this new thing that I have not shown you before, but we're going to introduce what's called a frame delta. Okay, and that sounds scary, but we'll get into that a little bit later. It's basically, you know, how long we expected the frame to take versus how long it did take, and then that gives us sort of a way of speeding up and slowing down movement in the game as the frame rate varies on the computer, so that it sort of always looks like it's at a specific frame rate. And that, by the way, that is how all current video games handle that. So, you know, frame rate, right, is like the number of frames that tick per second. So if you have 120 frames per second and your speed, you know, in the x direction is 2, for example, right, then twice the frame rate equals twice the speed, so things should be happening twice as fast. But if we take, you know, if our frame rate is twice what we want it to be, and we have this delta in here that we just multiply by the speed, then that will make the speed half of what it normally is, because the frame rate is twice of what we want it to be. And then that will make us move, you know, it will make us appear to be moving exactly as fast as we normally do. So that's how that works, and we're gonna implement that a little bit later. But for now, I just want to start including it in all the update functions, just so that we have to do less later when we actually do implement it. Okay, and so for that, we are going to go into our component, update double delta. Okay, it still doesn't do anything because, ooh, is this not abstract? That should have been abstract, I think. Let me just, yeah. This definitely wanted to be abstract. Not sure why it's not. Okay. The update we are going to make abstract because we don't necessarily want every component to update. So add public abstract void update like that. So if components need to get updated, then they can be responsible for that themselves. Okay. And then we'll just leave that for now. Go back to our display panel. Okay. So now, if our components is not a null, then we're just going to loop through them, and I'm going to use this particular type of for loop here. So for component object, okay, so you notice the capital C, so for component object, and then I'm going to do space, and then a name for the current object we're referencing. So we'll say comp. And then I'm going to do a colon, and this means in the components list. So for each component object in the list of components, we're going to loop through them, and at each one, we're going to have a reference to the current one that we're looking at, and it's going to be named comp. Okay, so this means I can access it. So this is the same thing as doing this. Components of size So it's exactly the same thing as saying component comp equals components dot get I in a normal for loop. Okay, so these two here are the same thing now. Okay, so I can reference comp in exactly the same way. So you know I can look at comp dot height, right? Comp dot height, exactly the same thing. Okay, so I'm going to be using this kind of for loop quite a bit more frequently, and I just wanted to explain what that did just briefly. Okay, so for each component, we're going to do comp.render, or sorry, this is update, so update with delta, like that, and that's it. And then we'll basically just do the same thing with our render function. So public void render with a graphics 2D object called G. We have to import this. And we're just going to basically just take this and copy and paste it down because we want to do exactly the same thing, except instead of update, we want to render with G. Note how I'm updating the background first and rendering it first. That way it renders in the back because everything else gets rendered in front of it. Okay, so render G. Cool. So now we have this way of you know, basic updating and basic rendering for all our components in a display panel, and so that's pretty nice. Now what I want to do here is just get into a little bit of the commands. Okay, so like I mentioned, we want to have these commands that allow the display panel to interact with a state. And the way we're going to do that is we're going to make a protected, don't know why I can't type today, a protected hash map. Okay, and I haven't explained what these are. I'm not entirely sure if that was part of your like programming education, what a hash map is, but basically we have a key and an object. So our key is going to be of type string and our object is going to be of type command. And we can access the object by inputting the key. Okay, and so what that means is maybe I want to access a command that has a name. Like, you know, let's say the name is update command, right? So I can say commands.get, and our key is of type string, so it would say update command. Okay, and so this would return a command object, right? It would look through the list for the object associated with this string, and it would return that. And so then I could just say .execute, right? Just like that. And so this will allow us to store all our commands with a string instead of an index, and that just makes things a little bit easier for us to handle from a development standpoint, because we're going to be making a lot of these commands. Okay, and so we can access them just by a string and execute them from there. So that's going to be pretty nifty. And we are just going to initialize that in the constructor for the abstract display panel, because all display panels are going to need to have a commands list, so we'll just throw it up in here. So it's going to be a new hash map of key type string and object type command, and that'll be it. Okay, so now we can officially add things to our commands when we want to. But again, this is an abstract class, so we're not going to be doing anything. We're not going to be giving it any commands here. We're just going to let all of our other display panels do that. Okay, so the way we're going to handle these commands with interacting between states in the display panel are that we're going to let the states actually attach commands to a display panel, all right? So we really just want the display panel to be building itself and showing stuff to us, and then we're going to give it commands to execute, all right? So to do that, we're going to make a function that is called attach command. So public void attach command is going to input a command called C. All right, and I guess we are going to need, an ID. That would make sense. So we're going to give it an ID and a command called C. And so with this, we're going to say first, we're going to do a lot of checking here in this abstract class, just so we don't have to do any checking later. So we're going to do if our command list is not null. Actually, no. We'll make it null. All right, we'll check to see if it's null first. If it is, then we're just going to initialize it right here. So maybe something later down the line will give it the potential to be null when we try to attach a command to it. And just in case it is, we'll just give it that check there every time we try to attach a command. And if it is, then we're just going to make it, we're going to initialize it here. And then we'll do, I believe it's put, yeah, commands.put ID C, and bam, there we go. We've now added the command C with the key ID to our command hash map, and so we can access it from anywhere now. So that's really good. While we're at it, let's make a way of adding a new component. Public void add component C, and we'll just do components.add C, like that. Although we should check if our components list is equal to null, like we did above with the commands, and if it is, then our components will just components equals new array list of components like that. Okay, so now we have a little bit of error checking there. We have a way to add a component. Let's do a public void remove component C. All right, and we'll check to see if our components contains that object. And if it does, then we will remove it like that. And we also want a way to remove a component at an index, just in case we ever have the index but not the actual object. All right. And now we're going to make a whole ton of abstract functions, and these are all going to be specific to display panels. So we're going to make, we've got our init components, so we're going to make a specific panel render function. We may or may not need this. All of this I might delete or refactor a little bit later down the line. So we're going to do a public abstract void panel render, just to give each panel its own special rendering functionality if that needs to be a thing. Excuse me. We're going to make a let me think. We'll make the input processing stuff now, actually. So we're just going to have each display panel handle all the input processing that it's ever going to need to do. So it's going to take a mouse event called E in this function called mouse pressed. You just import that. And we're going to do the same thing. So we're just going to copy and paste that a couple of times, but instead of mouse pressed here, we're going to do mouse released, and for mouse pressed down here, we're going to do mouse clicked. And so these are 3 different kinds of mouse events that can happen. And I believe we can do 2 more. There should be a mouse moved option, and there should be a mouse dragged option. So these are a whole bunch of different kinds of mouse events that can take place, and Java will actually give us a unique notification for all of them. So we can process all of these differently. So mouse pressed means that you have clicked the mouse button, right? The button is pressed down, right? But you have not released it. Okay, so just click and hold, right? And that counts as mouse pressed. And then when you release your finger off the mouse button, then that counts as mouse released, and then mouse clicked counts as pressing and releasing quickly. So that's a click right there. I'm clicking my mouse, right? Mouse moved means that the mouse has been moved around the screen, but no mouse button is down. Okay, so you have not pressed a mouse button, but you move the mouse around on the screen. And then mouse dragged means that a mouse button is down and you're moving the mouse around on the screen. Okay, so this is a mouse dragged event that you're seeing right here. All right. So there are a whole bunch of different kinds of mouse events that can take place, and we're just going to have a function to deal with all of them, and we'll let our display panels figure out what they want to do with each of these events later down the line. And we're going to do the same type of thing for key events. So public abstract void key pressed is an event, and that's going to take in an object key event E, and we'll do a public abstract void key released with a key event E, public abstract void key typed. The key event E, like that. We'll just import key event. That should come from aught, just like mouse evented. Okay. So now we've got all this stuff, all these input processing things. We've got a specific render. We've got our initialize components function. Just make sure that we're going down here and we're doing our panel render like that. Just so that we do all of our abstract rendering, and then we let our panel do its thing after all that is done. Might do a panel update as well, but I don't think we're going to need to. We'll see. We may add or remove a couple of things as we discover that we do or don't need them for any given implementation of this stuff, but for now it seems like that's pretty good. We can probably leave it there for now, and you know, tackle more of that later. So let's go on to what we're going to need for our components before we deal with states, because components are sort of a part of our display panel, and our state needs the display panel to be working before we want to deal with that fully. So we need to do a lot with these components. I discovered quite a few problems with dynamic rendering and updating, stuff like that, and it took me a while to sort them out. So we need to change a lot with this. And what we do end up changing is actually going to have to be, with the rendering, is actually going to have to be, you know, sort of propagated out throughout all of the rendering that we have been doing up to this point. So that's going to be sort of a refactor that we're going to have to deal with later on. But it shouldn't be too bad. It should only take a couple of minutes once we actually need to do it. We won't do it now, but that's just a sort of a heads up for the future. Okay. So, for this, we're going to need our texture, our width, height, and our position. And now, let's get into the nitty-gritty of it. So we want each component to have a potential protected component for its parent in case we want to attach one component to another component. We're going to have components responsible for loading their own textures. So we'll have a file IO handler called IO handler. And we will import that. And this will be protected, of course. Okay. We want each one to have an ID, which will be a string. We want it to remember the location of its texture, just in case we need to access that later. And here's where things get a little bit tricky. So we want a protected affine transform for this called T. And we also want another protected affine transform called graphics previous. Okay, and I'll explain why we need that in a moment. And then let's just give it an outline like I had shown you. So we'll save a color called the outline color for each component. Maybe they can each have different outline colors if that's what they need. Import affine transform and import color, just like that. All right, cool. All right, so now let's make a ton of constructors. Okay, so we want a whole bunch of different ways of instantiating a component object, and for each of these different ways, we want them all to do, you know, similar things. So we're just going to make an init function here, and we're going to take all of this. And I believe we can just throw it all down in there, right? Yeah. So we'll take init, we'll throw that all down in there, and we'll say parent equals null in this component thing, and then we will do init. And instead of text, we'll do texture, texture, texture. Okay, so this is our init function. This we're going to have happen on all of the constructors. So let's just public component. So this constructor allows us to pass a buffered image that's a preloaded texture. We want a constructor that takes in a string called the texture path, and we will have that set our parent equal to null. We will init, and then we will load our texture. like that. And we'll make that function in a moment. We want one that is completely empty. And that will just call init and set parent equal to null and texture equal to null. So this, maybe we could just have this lying around and load a texture into it later. Okay. And let's see, let's make another constructor that allows us to initialize this with another component as the parent. So parent would be equal to, we'll actually call this p. So parent equals p, texture is equal to null, init, like that, and then we'll have one final constructor, so public component that takes in a component that's the parent, and it takes in a string that is the texture path, like that. So we'll say parent is equal to p, and we will init, and then we will load texture with the texture path. Okay, and so all that I've just been doing here is just giving us different ways of instantiating this type of object. So we have a whole variety of options when we want to instantiate a component. And this just allows us, to, depending on what type of component we're dealing with, where we want it to be, how we want it to behave, we just have a whole bunch of different ways of initializing it without too much hassle. Okay, and so let's dive into this init function here. So we need a little bit extra in here. We want an IO handler because remember we do have one of those. So new file IO handler. We need to initialize that. We've got our affine transforms that we threw in there. All right, we want to put that in there. We do not want to initialize the previous graphics affine transform because that's actually just a piece of memory that we're going to use as a reference later down the line. We want to initialize our texture if it is available, or deal with our width and height and stuff like that. Just in case. So this block right here is only going to be useful if this constructor is used, because you'll note that we load the texture after initialization each other time. But that's okay. We don't really care about that. If our parent is equal to null, then what we're going to do is initialize our position there. Okay. Otherwise, I don't know. Let's say we'll do pos is equal to new integer array, and we're going to fill that. Let me just tab these over so it looks good. We're going to fill that with parent.getX and maybe parent.getY plus parent.getHeight. So this will just attach this child when it gets initialized to the parent component. Okay, just need this here, and that goes away. This will just attach it to the bottom of the parent component. We don't necessarily want this behavior every time, but this just gives us, some kind of starting point to look at the types of ways we could handle having a parent component. We can make that a little bit more robust later if that's something that we want to do. And then finally, we're going to translate our object here to our position, or not our object, translate our affine transform over to our position. Okay, so that's our init function. And now let's tackle, I guess, load texture would be a good thing to do next. So let's do public void load texture. It's going to take in a file path, and we're going to just save that file path to our texture location object. What is this? Go away. And then we're going to make a buffered image called image, and we will load with our IO handler, load texture from the path, like that. Finally, we are going to set our texture to set texture image. Okay. So that's all well and good. Let me just change this up in the component thing here where we pass it a buffered image. We are going to call set texture. This just allows us to make the behavior of set texture a little bit more predictable. So everywhere in the code that we want to change our texture, it's always going to do the same thing. We don't have to copy and paste a bunch of times. Just make one function called set texture, like that. And it'll take in a buffered image called image, or img. And you know what we'll actually do? We'll actually just go ahead and take this bit of code out of init, and we'll put that right in there. Change that to image, and then image.getWidth and image.getHeight, and that'll just make sure that every time we're setting our texture anywhere in the code, we're always dealing with our width and height, so that never gets forgotten. And then we're dealing with our texture itself, so texture is equal to image. Otherwise, in this else here, width equals height, which equals 0, and then texture is equal to null, and we'll just return right there. Actually, we don't need that because this is in the else statement, and it's the last thing that happens. So we'll just do that. Maybe we'll print out sysout error setting component texture, and just to give us something a little bit of information that happened. Okay, great. So now that we've got that set up, we have a nice little way of loading textures, a nice little way of setting textures. This is going to be helpful to have later on. We're going to want to know if our component is being intersected by something. So let's do a public boolean intersects, and we'll give that an int x and an int y, and we will say if x is greater than or equal to our x position and x is less than or equal to our x position plus our width. Okay, so if it's inside the boundaries of our our texture's width. Do another check if y is greater than or equal to position sub 1, and if y is less than or equal to position sub 1 plus our height, then now we know that it intersects, so we'll just return true. You don't need these if statements here. You can actually just take all this Boolean logic right here and throw it all together in a bunch of ands, and then have it return just that Boolean logic. But I think that looks gross, and I prefer this if statement method because it's a little bit prettier, so that's what I use. Otherwise, we're just going to return false. If either of these two does not go through, then we're going to return false, because we're guaranteed that it's not intersecting. And then we're going to make a wrapper function to that. So we're going to make another function with the same name, but this one is going to take in a mouse event. Okay, so in Java, you can make two functions that have the same name as long as they take different arguments. Whoa, what is with this? Why is this doing that? Okay, that was weird. Okay, so intersects, and so now what we can actually do is mouse events come with an x, and we can access it by just doing .getX, so event.getX, and y is equal to e.getY, and so now that we have the x and the y, we have this nifty little function that we just made to check if an x and a y intersect with us. So we're just going to return intersects with x and y, and bam, there we go. So now we have a way of checking if coordinates intersect with us, and we have a way of checking if a mouse event specifically intersects with us. Okay, and so we could wrap this intersects function in any number of ways, depending on what kind of stuff we want to check, and it'll just make things a little bit easier later down the line. Okay, so hopefully that's not too confusing. Set pause is annoying me that it's up there, so I'm going to put it down here. All right, let's tackle rendering. So rendering was a bit of an issue. I found that the graphics object was basically getting transformed by all these different components, and it was also trying to get transformed by a bunch of different images at the same time. And so it was basically shifting itself around frame by frame. Okay, because of the way, I guess, that Java does the rendering loop, it would basically accumulate this offset in the graphics object, because the graphics object would get transformed, and before it could get transformed back, using the inverse transform that we had been doing, the graphics object would get transformed again by a different component somewhere down the line. So there's clearly some asynchronous stuff going on with Java that I don't really understand why it's doing that, but I don't have control over it. What I do have control over is whether or not I allow that to be a problem. And I will do it like this. So we're going to do a try catch here. All right. And we're going to take the graphics previous transform, and that's g.get transform. So this is what the graphics object is currently transformed to, and we're just going to save that. All right. Then we're going to apply our own transform. So g.transform t. Okay. Then we're going to draw our image. Draw our image at 0, 0. All right. And then we're going to check if our outline color is not equal to null. We're going to set the color. Why is it doing that? That was weird. Set color to outline color. And we will do maybe a rectangle. So g.drawRect at pos 0. Pause 1 with height, just like that. So that'll just draw a little outline, a rectangular outline around us. That might be helpful. And then what we're going to do is we're going to do g.transform to graphics previous transform. Okay, so this just gets wherever it is currently and transforms it back to that, instead of relying on the inverse transform of our transform matrix. And that basically guarantees that it's always going to get forced back into the right position, and so that's what we need to do. Okay, other than that, all we need to really do is make getters and setters, and then also deal with set pause for components before everything is going to work. So for set pause, all we need to do is deal with our transform object, so we're just going to reinitialize it like that. And we are going to translate it to the new position. Okay, and this just allows us to, reset where we're at and translate our, our affine transform object over to the new area that we want to be in. Okay, with no relation to where we were previously. Alright, so now we've got that, we just need to do a whole bunch of getters and setters. So basically for all of these things we want getters and setters. So I'm going to do that off camera, and you can do that on your own as well. Otherwise, I'm going to end the video there. We've made some decent progress, but there is a long way to go. I'm going to try and do maybe 1 or 2 videos a week. Hopefully, we'll make some decent progress through this and it's not too confusing. If you have any questions, just DM me or talk to me in voice or whatever. But yeah, hopefully one video a week, possibly 2 videos a week, depending on what the homework situation is like. But there's a lot more to go through, and I've got all the code ready. I just need to actually sit down and record a video and then upload it. So hopefully we'll be able to get the ball rolling on this, and things will go pretty well. So I will see you later.